Hey, last session of the day, huh? You guys still alive? Still sort of alive, barely. All right. I'm so excited to be sharing a talk with you today called Kotlin Everywhere. My name is Pamela Hill. I'm an Android engineer at Luno, which is the cryptocurrency startup. And you can find me on Twitter at Pamela A. Hill, and I have a blog, pamelaahill.com. All right. So today we're going to be conducting an experiment. And the experiment is, can we use Kotlin to create a full-stack web app? So I'm going to start you out by saying, okay, why Kotlin? So I was in the lunch line today, and somebody asked me that exact same question. Could it be topical? All right, so I'll be answering that. And then I did a short project to kind of prove my hypothesis of this little experiment. And I'll be introducing that project to you and showing you a little demo, because I don't believe in demo gods. It's recorded. It's recorded, guys. Don't worry. And then I'm going to start introducing a backend with Spring Boot. Then we're going to do an alternative backend with Ktor, and then a front end with React and Kotlin.js. Finally, we kind of have to go, okay, well, this was a cool experiment, but does it actually work? Can I use this in production? Can I suggest this to my manager or to my architect without getting fired or laughed at? So why Kotlin? Now, I'd like to ask if you've kind of worked with Kotlin, you've experimented with Kotlin before, so I'm amongst family. So I was privileged enough to attend KotlinConf in Amsterdam last year. And one of the major things that was said in the keynote is Kotlin is about love, about code love. So why Kotlin? So Kotlin really supports more comprehensible code, more understandable code, more readable code. And the way that it does this is sometimes by being super concise. If you think about data classes where you don't have to generate a getter and a setter and a toString and a hash code and equals and a copy method. That was quite a mouthful, right? Or, and then it's super concise. It's not even generated for you by the IDE. It's actually just there. You can assume it's there. You just work with it, and you don't have to read it. You don't have to test it. And it's perfectly working, and it's just so concise and so nice to use. But sometimes more comprehensible means less concise. If we look at named arguments, for instance, you could, for instance, you could be very explicit about the way that you specify a argument corresponds to this parameter, argument corresponds to this parameter. So you give a lot of context in what you're doing. Kotlin supports safer code, less buggy code. Now, I don't know if there's anybody that's kind of like into dynamically typed languages here, but I'm a statically typed person. I like my compiler to kind of figure things out for me and kind of tell me ahead of time, ooh, no. So I'm a statically typed person, and it also figures out for me a lot of times ahead of time, that there's not going to be an error in production. So as I said, Kotlin supports safer code, and it also really works on nullability. So you have to really be explicit. Is this variable ever going to be null? And then if it's ever going to be null, you have to handle every single case. Now, I'm an Android developer, so the biggest cause of crashes, BJ, null pointer exceptions. And now we just have other reasons for crashes. All right, it also supports different programming paradigms. So object orientation, yet you can have top-level functions and constants. It supports functional programming, your higher-order functions and your lambdas. But if you want to be more advanced, you can use libraries like Arrow to get like super fancy. It's also really fully interoperable with Java. So you can call Kotlin from Java and Java from Kotlin. Now, another lunch line kind of conversation was like, Really? You can do that? You can. All right. So in terms of framework support, it's really growing by the day, what's being supported by Kotlin. So at the moment, we have things like Spring, Spring Boot, and Ktor, but there was actually a very good talk by Ken Yee at KotlinConf 2018 about comparing the different platforms or server backends that there are for Kotlin. So it's really exploding. In terms of multi-platform support, so we actually have different flavors of Kotlin. We have Kotlin JVM, Kotlin JS, and Kotlin native. So for Windows or iOS or MacBooks, we have Kotlin native as well. So what you can do is you can kind of extract that code and really use that code wherever you need to on the different platforms. So it's super cool. So I'm an IntelliJ and an Android Studio fan, so I am a little biased, but the tooling there, it really is excellent. I like copy-pasting, especially like copy-pasting Java code into IntelliJ, and it says, would you like me to convert it to Kotlin? I would. Yes, I would. And then the last thing that's really like a hot topic right now, it's the theme for Kotlin in 2019, is coroutines. So I read today, you know, one of those TIL, Today I Learned, coroutines was actually built for COBOL really long ago, like in the 60s. So coroutines isn't a new thing, but it's a really great thing because of the way that it actually allows you to program. So it's asynchronous, but it reads like synchronous code. It's very performant, it's like lightweight threads, but it's like super easy to understand and kind of reason about. So that's roughly what's happening around Kotlin at the moment. So let's have a look at the project that we're going to be working on today. So obviously we're doing this experiment, so we have to have a project. And the project is to create a full stack web app to generate absurd inspirational quotes. So on the right-hand side, you can see that there's a little screenshot of what the actual project looks like. So it's basically based on a website that came about a couple of years ago called InspireBot. Does anybody remember InspireBot? Was I the only person that wasted hours of my life on that stupid thing? But it was, it's basically purported to be this AI that generates these inspirational quotes for you. And it usually turned out to be like really sarcastic and really like, what? But anyway, I thought that would be fun. So some of the inspirations that it can generate is very deep. There's a little intellectual inside each and every one. The dark, consider that dating is like medieval torture. It is. It is. And the absurd, sleep is a lie. With a bunny costume. All right, so as I said, I don't believe in the demo gods, so I recorded my demo, and let's hope it plays. All right. So I've generated my first inspiration. I call the little picture inspiration, and I'm going to generate another one now. So whenever I generate inspiration, I save both the image and the data structure to the backend onto a database, and now I'm adding some tags. I'm adding people and mountains, and now I'm going to, like a crazy person, add a crazy tag, and then remove it again, just to show you some stuff. And I'm going to generate another one. So I was very careful about what that I didn't live generate them, because some of the InspireBot things are a bit. All right, so as you could see now, I basically saved all those inspirations, and then I went and searched for people, and the tag people. And sometimes you'll hear that I refer to it as a chip. So please excuse me. In material design, that little round button thingy is called a chip. So what I was doing is I was searching by the tag or chip people and then returning these two inspirations. And that is my demo. Okay. So obviously I have a front end and I have a back end and they have to communicate in some way. So I wanted to write down for you just roughly what the API looks like. So the first call is really the most important because that's what we're going to be exploring in our examples. But to get a new inspiration, to generate this image and to save it to the backend and save it to the database, we obviously use the HTTP verb post. And we specify that we want, for a specific user, an inspiration. Then to get that image, we have to specify the user and the inspiration ID that we just created, and say image. Now, I made a mistake here in the next call. So I wanted to change the tags for the inspiration. So a prize that doesn't exist, to anyone who could figure out why, if I was passing in a JSON array to this call, why would that actually be wrong? Is put the right version? Is it the right verb? No. It should be patch, sorry. So patch actually is if you pass in just a section of the object that you want to update, and put is for the whole object. Sorry. Okay. So to find a tag by title, we specify the get verb and we specify the title. Finally, to get the inspirations by the tag, we get the inspiration by the tag ID. Are there any Spring Boot fans? Java Spring Boot fans? Just one or two? 4. Okay. I was actually kind of thinking that there would be more Spring Boot people. No? Okay. Well, for the Spring Boot fans, I've created a backend with Spring Boot. Now, you'll wonder why I created 2 backends. So I wanted to compare and contrast the more traditional Spring Boot with something new from JetBrains. And there's also a library called Spring Foo, which is still experimental from the Spring Boot guys, but it is very much experimental, as I said. It's based on coroutines, it's DSL based, but I didn't want to show you something experimental. And I didn't want to show you, I want to show you how to migrate from Java to Kotlin using Spring Boot, rather than something new and fancy that you might never use. So let's get started with Spring Boot. So a few of you have seen Spring Boot before, but for those of you that actually haven't seen it before, it just simplifies how you create services with Spring. It's really easy to set up, and it's really easy to deploy. I was very surprised and I was very delighted by the way that it was just really, really simple. And it's also really easy to access data using JPA and the Spring Data stuff, and you can support you get the support of the whole Spring ecosystem. But since 2017, Kotlin has now gotten full class support, first class support from the Spring Boot guys. So it's not just for Android, guys. All right, so this is roughly what a Spring Boot application would look like. You get your client and your server. And as a HTTP request comes in, it sort of goes through a REST controller. And then the REST controller passes it on and kind of works with entities and repositories, and those repositories would actually do something on the database. I used H2, a sort of a relational database to affect our data. And then finally, our response would come back. So to create the project, as I said, the setup is super easy because we use a project called Spring Initializer. Then we secondly have to create this application. We create the entities, the repositories, and then the REST controllers. So I'm kind of moving like this. I'm moving a little bit back. So this is Spring Initializer. This is the website, but you can also use the intellij plugin. And all that you need to do is simply specify, do I want Maven or Gradle? I like Gradle for Android in Android Studio, but I preferred using Maven here. And then obviously you're going to choose Kotlin. You'll specify what version of Spring Boot you want. But the reason why you're using Spring Boot, Spring Initializer, is the dependencies on Spring Boot actually gets very complicated to get right. You know, you're not always sure, should I be using this dependency with this one? So Spring Boot makes it super easy. Then you specify the project metadata, and the dependencies that I selected was web, JPA, and H2. So web is really for just the servlet container, JPA for the persistence, and H2 because I'm lazy and I want to use an in-memory database. So whenever I shut down the server, the data goes with it. I was thinking of making a joke about MongoDB, but I'll just leave that. I did. All right. So this simply is the application. This is all that there is to it. We create a class, InspireBot application. No braces necessary because Kotlin is really succinct. We annotate it, and then we run the main function with this application. And that's really, in terms of creating the application and getting it started, that's all that there really is. Next up is our entity. So inspiration, so that's that little image, has a couple of fields that's associated with it. The user ID, because we're kind of specifying, we're kind of restricting the access of users, inspirations to users. Then a file URL, where's it stored? The tags, and then the generated date. Now there's a couple of interesting Kotlin features happening here. First, I'm using a data class. Now a lot of documentation says don't use a data class, but I found some other documentation that actually said, okay, these are actually the ways that you can fix the fact that you can't use a data class. So the first problem with data classes is a data class already has a constructor. So with Spring Boot, and Hibernate, you need a default constructor. So all that you have to do is you include a dependency called Kotlin Maven no arg, and then you've got your default constructor. Then in terms of data classes, now with Hibernate and Spring Boot, you really need to focus on the entity's ID in order to kind of do a find by ID and so on. So the problem comes in is with data classes, it generates the equals method and the hashcode method for you. So all that you have to do then, you override them. But I want to show you something else. So notice how I used default arguments. So whenever I create an inspiration, it's going to be very, very quick. I just specify the user ID and the file URL. The tags, by default, I don't need them. The generated date, I'll never need to specify. So that's it. Okay. Now, I was really impressed with Spring Boot in this way. The way that it actually does CRUD repositories. So it's create, read, update, and delete. And this literally is all I needed to do to interact with the database. I was like, really? This is all? I was so impressed. So it works by convention. So instead of saying, instead of implementation. So instead of saying I want to find by user ID and giving this whole implementation, exhausting yourself, you can just specify I want to find by a named kind of field. I know what user ID is because it's a field in my entity. So why can't you figure out that it's find by something that I have a field for? And I was really super impressed with this. And this is literally to do things, because I'm extending CRUD repository, which already gives me a lot of bang for buck, Things like save all, find by ID, delete by ID. It gives me everything that I needed almost. I just needed to find 3 little methods and not even implement them, just define them. So I was very impressed by that. And then finally, you have to create my REST controller. So we've been moving from the back, the back a little bit forward. So I specify the REST controller and then the path that I'm going to. But notice how I used the auto wirings that's part of Spring and Spring Boot to create and inject my dependencies. So I thought that was also pretty cool. I like auto wiring. I like the Harry Potter magic in my software. I know a lot of people don't. There was actually, at the Kotlin Conf, there was a talk specifically removing all the magic out of Spring Boot and stuff and being more explicit about it, which I kind of didn't like. But, you know, to each his own. Okay. Okay, so in terms of how I actually went about implementing the request and so on, I created a function which maps to a post mapping, and I got a path variable inside that is required. And first I basically go and call the web service, the InspireBot website, to get the URL of that image. Then I get the image, I save the image, and I use my repository to go and save that image and just return the inspiration and just return it back. And that's pretty much it. So literally, that was the backend with Spring Boot. You can find the rest on InspireBot Spring Boot under my GitHub repository. Any questions so far? Are you still alive? Okay, I'm glad. All right. Has anybody ever heard of Ktor? Oh, about the same amount of people that know Spring Boot. Wow, okay. You know what? I actually thought that there were going to be like tons of backend people. How many backend people are here? How many Android people are here? Ah, okay. So there's a nice mix. And then front-end JS kind of people. Also, hey, it's a nice mix. Thanks, guys. Thanks for coming. All right. So what is Ktor? It's obviously a backend technology, but it's also it's really there to create async clients and servers. So the flavors of clients is a lot more diverse. You can use Ktor to create JavaScript clients, Android, iOS, and JVM. But the server flavor is a lot more kind of limited. It's just the JVM servers. It's built from the ground up on coroutines. It's also very DSL-based, and you'll see that illustrated very nicely because I sometimes want to create talks called Fantastic DSLs and Where to Find Them, because I really love DSLs. It reads so fluently. It reads like natural language. And that's when you program, that's actually what you're attempting to do. You're attempting to create code that's both beautiful to read and understand and performant. So, and obviously solving the problem while you're at it. The setup was super easy. You download and use the IntelliJ plugin, and it's production ready. So there is a website called HLTV, which is a sports website that actually uses it in production. And ThoughtWorks, which is a thing, put it on their technology radar as the assess category. And that basically means just assess how it's going to fit into your enterprise. So this is what they said about Ktor. They said the flexibility to incorporate the different tools for DI and logging and templating, in addition to its lightweight architecture, makes Ktor an interesting option for creating RESTful services. And ThoughtWorks is like, I don't know if any of you've read about it before, but it's a really reputable company, and I really respect their opinion. So I think it's a really good assessment. So let's have a look at how the client and the server kind of fits together. We've got our client and our server, and we've got our HTTP 1, 2, or WebSocket requests coming in. Now the application first transforms this request to an application call. In the DSL, you'll see it as simply call. And then it goes through a pipeline of interceptors, sort of asynchronous interceptors, that does stuff, and then we get a response back. You can also think of, and we'll go through the architecture in this way, of a K2R application as a pyramid. It's firstly, you work on the application, and the application is built on modules, the modules are built on features, and finally, you get the whole application structure. So application is really there for, as I said, it's built on modules, which is going to specify your application behavior. And this application behavior is simply to install and configure some features. And these features install and configure pipelines, pipelines. And examples of features are things like content negotiation or routing or authentication, so important stuff. Okay, so as I said, we're going to go through this step by step. We're going to start with the application, and this is all I need to do. I simply run my main function, and I create a little server with a module, InspireBot. That funny annotation that I've got, or notation that I have there, is just indicating that InspireBot is an extension function of application, which you can see here. Now, extension function means I don't actually go and change the code of application, I just enhance it a little bit. So I was naughty and I didn't use dependency injection here, sorry. But the way that I think there's other more important things happening around here, like installing the features and kind of configuring them. So first I install the content negotiation feature, and then I use it. I don't have to install routing because it's such a common feature that we actually don't need to install it. It comes pre-installed, and then I do some routing on it. So routing would be, I know what verb I'm getting, what my HTTP verb is, and I know what path came in, so I can kind of figure out what functionality I should be using with it. So to create my inspiration, I needed to create sort of a route for my post method. And first I get and check the user ID, I create the inspiration, I save it, and I return it. Sorry, I'm not used to talking so much. It's like for programmers, we're always like, oh, okay, that meeting was super long. I can only talk for like 5 minutes at a time, and then it's over. But here we go. Okay, so I mentioned before that we could transform the request into call, the application call, which we just refer to as call. And we just get the parameter, user ID from the path, and we kind of check if it's there. If it's there, if it's not there, then we can say, hey guy, you called my API with a bad request. And then finally, if we want to actually go and create the inspiration, we call the API, which is our website, the InspireBot website. And if we actually can't get it, we give an error. And the same goes for if we try and save it to our local database, and we can't save it for some other reason, then we just give an internal server error. But if we have a happy case, then finally we just return with call, a respond with the HTTP status we created, and the inspiration. So I mentioned before that K2R can be used as a client and a server, and here's how I actually used the server, the client side of things, which is more, which is now going to call the website, the InspireBot website. So I created HTTP client, which I'm passing a CIO. Now the CIO is coroutines. It's a coroutines IO. And I get, using this HTTP client, the URL of that image, and I just return a URL. So I've basically demonstrated both that you can use Ktor as a client and a server using Kotlin. For the database access, I used a framework called Exposed. Now, this is also a JetBrains a sort of framework or library, and it's really there for relational databases. So some of the databases that are supported are things like H2, which is what I use, but it's stuff like Postgres, SQL Server, Oracle, all the big names. Then we also have what I used H2 as an in-memory database, and then Hikari CP for connection pooling. So in order to now save this inspiration to the database, I actually use a suspend function. Now, whenever you read things like suspend, you immediately should think coroutine. So what this is actually saying is, this is going to be a long-running operation. So hang on, I'll be back, and I'll come back later. But don't block the thread that I'm currently running on. So all that we need to do is kind of switch the context to the coroutine context to an IO context, save the file, insert it, and find and return the inspiration. So what I want to show you here is how nicely this DSL actually works. I think the most fun that I had on this project was really writing this the exposed DSL sort of database lookup code. It was maybe a little bit of a waste of time. There is also a DAO kind of implementation for it, but I decided I want to use the DSL, and I wanted to kind of compare and contrast the way that Ktor and Spring Boot work. So this is basically going to, inspirations is your table, and we're inserting the data into the table. And then we're operating on the row, and it is actually referring to the row. So each column is being set in that DSL. So we're setting the user ID, the file URL, and the generator date. And then finally, we use a nice infix operator operation called get, and I go and get my ID. Here's another example of what the DSL can do, but looking really like super fluent. Notice how I'm selecting from my inspirations table. I'm trying to find my ID, that inspiration corresponding to my ID. But now I've got this column, and I want to see whether it's equal to an ID. So I don't say something like column dot is equal to ID. I specify equals ID. And that's the way that it actually reads is like really natural language. And that's also really like super important for Kotlin. There's a very good talk by, who was it, PJ? Venkat Subramaniam, that did a fantastic talk on external DSLs at DevConf. And just the way and the power that you can actually create this really beautiful code that's performant and does what it does, but it's also like super readable. It was a really great talk. And I know I keep on talking about KotlinConf, but it was probably one of the best conferences that I've ever been to, except for this one. So it was a really good talk and a really good inspiration to use DSLs. So the rest of it you can find on my GitHub, but I really want to get to the front-end part with React. So amongst those that do a little bit of front-end or maybe full stack or whatever, who of you actually use Angular? Okay. Any React people here? A few. Okay. Because React is actually used not so much in South Africa. It's used a little bit, but mostly people in South Africa actually use Angular. So you'll be wondering why I decided to use React, and I'll answer you in a second. So what is React? It's a JavaScript framework for building UIs. It's very component-based. So we have small components that build up larger components successively. It's an alternative to Angular and Vue.js. So I'm not going to do the whole React Angular versus Vue.js fight. That's your problem. So the reason why I chose React is, and it is maybe a little cheating, is there's a Kotlin.js React wrapper library. So all the interfaces, all the functions, it's all neatly wrapped up for you in Kotlin. Okay, so just a brief React 101. So the important thing to remember is the properties flow down and events flow up. So in my app, I had the app component, I had a home component, and I had an inspiration component. That's just a little image. And under the home, I also had a chip editor, which was my text box and button, and I had a whole bunch of chips. For the search component, which was whenever you clicked on the search section of the navigation, it also had an inspiration and some chips underneath it. So, for instance, how would I illustrate that the properties flow down? Now, properties are something that goes from the parent to the child. So, if you have a chip, you obviously want to convey to it what title it must show. So the home component would actually specify to the chip, hey, show me people or crazy or mountains. And the chip would say, when it's dismissed, please dismiss me home. So the properties flow down and the events flow up. So the setup was super easy. There's a project creator called Create React Kotlin App, and you can just create the project using that, and then you start with your npm start. It's live reloading, so you can do pretty fast development in this mode. It was actually, I really enjoyed the front-end side of this project as well. So to create a component, all that I need to do is 5 things. First, to define a properties interface. So properties, something that the parent would like to pass on to the child. Then you would create a state interface. Now that's something that the component itself would like to kind of remember. It's the state of that component. Then you create a component templated with those interfaces. You implement the render method, which is going to display things, and you create a builder, just to make it easy to kind of incorporate that, that component anywhere you want in the builder. All right, so this is my properties interface. I'm going to explain just the simplest component that I have, which is the chip. So some of the things that I want to pass to the chip from the parent to the chip is the title. Also, whether I allow closing, because on the home component I allow the chip to be dismissed, and on the search component I don't. So I kind of specify that as well. And then a callback, passing nothing and returning nothing, maybe. Then I create the component. I didn't have to override the state interface, so I just specify the default state interface, and I override the builder render method. Now, you'll maybe wonder, why am I doing an extension function in another class? But the reason for that is now it's scoped. So it's only scoped to within chip component. Okay, so this was also one of the most interesting parts, which once again is the DSL. So this is a HTML DSL. We're creating HTML, but we're also kind of adding almost like code. We're adding Kotlin, and we're kind of mixing HTML. And what I liked about it is it reminded me a little bit of JSX. So the way that React works is it's HTML, but it's also JavaScript, but it's also, you're kind of mixing them up together. And so all that I need to do here is to create a div with some material design classes. So chip, fade, and show is material design. And then I add the text. If I allow the chip to be closed, I just add a button, and that button has a click function that actually has an invoke. So whenever I click that button, I will invoke my callback. So properties like text would flow down, and the events would flow back up. All right, the builder. So the way that I would actually go about and call this chip is the fundamental reason why you do all this fancy footwork. So when I want to create a chip, I simply say chip with the text. I don't have to specify all this other stuff. I don't have to do all this complicated code. The builder makes it super easy for me to create this component. And that's really all that there is to it. It's just creating a component and passing in to this component different properties. Now, I did cheat with the React wrapper libraries, say that a couple of times, but I am not cheating now. So in order to use just something that's not been wrapped, I just wanted to show you that as well. So to use a JavaScript library like Axios, which I use to kind of connect to the server, you install the normal npm install, and you create some external functions and interfaces in Kotlin. And then you treat it almost like normal Kotlin code. So I create an external interface. Now the keyword here is external. We're just telling Kotlin the implementation for this function, for this interface, is actually somewhere else. So we kind of link with JS module, Axios, the implementation, and our Kotlin interfaces, our kind of stubs using JS module. And then we define some interfaces to kind of make sure that we've got our type safety that is so important in Kotlin. And to call it, we simply call it. We use normal Kotlin, we define an object, we call the function, we get our callback back, and that's our data. All right, so you can find that also on GitHub under Inspire.React. But I think the most important section is this. What now? So I hope that I've convinced you, some of you, maybe all of you, to maybe experiment with Kotlin a little bit. But I would be irresponsible if I just said, yeah, go ahead, use Kotlin full stack. But there's a couple of considerations that you need to keep in mind. Firstly, documentation, the help that you need, because when you start out, you're going to need help. So Kotlin JS documentation, there's not much. There is a lot of documentation on JetBrains site, but in terms of tutorials, I've seen one by Ray Wenderlich. I haven't seen much else. The documentation on Ktor and Spring Boot, lovely. There's also a very lively Slack and Twitter community. You can go have a look at a Slack workspace called Kotlin Lang, and you get guys like Roman Ilizarov and all kinds of fancy guys that you read about on Twitter that are actually answering questions there. The setup section was super easy for all three of the projects. So you use the npm module for Kotlin JS, and for Ktor and Spring Boot, you could use the initializer, or you could use the intellij plugin. For Ktor, just the intellij plugin. In terms of skills, you have to know Kotlin. It would be a little bit difficult to first get started with Kotlin and kind of at the same time try and code this stuff all together. You have to understand how a DSL is constructed, how to use it, and that it doesn't look like, sort of dark magic to you. And then also you have to understand what coroutines is and how to use it. So I would suggest somebody from an intermediate level and somebody that's really eager to learn new things. You don't always get that. And then in terms of the effort required, it's a little difficult to kind of measure, because the backend with Ktor and you can't really measure the front end versus the backend. But the Spring Boot implementation took the least amount of time. Ktor took a little bit more, and the Kotlin JS took a lot of time. So in terms of recommendation, I would say if you want to migrate from Java to Kotlin using Spring Boot, I would say go for it. And I think that the Spring Boot guys would kind of agree with me. There's there's obviously a Spring One tour happening soon, and there's also a meetup with reactive programming and the Spring Boot guys actually coding full stack stuff in Kotlin coming up soon. And in terms of Ktor, I would say just wait a while. I would say wait for ThoughtWorks to say, okay, let's put it from assess into adopt. And with Kotlin JS, wait. You need help. You need people that are able to answer your questions on Stack Overflow. You need people that are not the language experts to answer your questions. You need tutorials. You need help. So I would definitely wait for a while. I would wait 1 or 2 years at least. Okay, so that was it. Thank you very much for your attention. It was really good to have you here. And yeah, I know that there were lots of sessions and lots of things, but thank you for my Luno family, my XDVT family, and all the other guys. Thank you very much.
Right, are there any questions? Okay, I'll just give you the mic.
So Kotlin Native is for iOS, and I'm an Android engineer, but I have not looked at Kotlin Native before. No. Anybody else? I'm not scary. Okay, I am going to be at the unpanel a little bit later, and maybe at the cocktail function, but please don't while I'm eating something. No. All right. But yeah, you're also welcome to come afterwards. I'm very happy to answer your questions. And if you're shy, just tweet at me, Pamela A. Hill.